Let's talk about architecture, omnichannel architecture. So we'll start with the problem we're trying to solve, and I think this is probably one that everybody in this room could relate to. So imagine that you are on a company's mobile app and you're going through some sort of process, you're buying a product, you're opening an account, you're doing something. You've spent like 15 minutes in this isn't quick, you're pretty invested, and then all of a sudden you encounter an error. And then you have to call in. So the mobile app tells you, like, call into the call center. So you're already angry and frustrated because now you have to call into the call center. So you call in, you wait for 15 minutes online or on hold, and then you talk to somebody, and then they say, hey, can you tell me what you were doing? So now, I just spent 15 minutes on your mobile app, but sure, I'll explain to you for the next 15 minutes everything I did on that. So now you talk through and you're like, okay, well, I was doing this and I was doing that and I had these problems. And they're like, oh, okay, I know what your problem is, but I'm not the right person that can handle that, so I'm going to transfer you to another person. So you get to the next person, and then you have to go through and explain for the next 15 minutes everything you've done. And then finally that person solves your problem. Super frustrating, super common. I would imagine almost everybody in this room has some variation of this problem where the right hand doesn't know what the left hand's doing. You're thinking in your mind, like, you own the website and you own the call center. How do you not know what I've been doing? But actually, as we know from engineers, if you didn't build the systems with that kind of connectivity, they don't know. Because they're a completely separate department, they have completely separate databases, those systems are not integrated, and that's kind of how our channels have grown up. But in today's day and age, clients expect more. In Vanguard, we call our customers clients. So clients expect more, and we'll talk about how you kind of integrate those to create contextually relevant experiences to clients that don't feel so disconnected. So when we talk about channels, what is a channel? It's not just the website or the mobile app, but it's the IVR, the interactive voice response, so the system when you call in on your touch tone. It's the call center agent, it's push notifications, it's email, direct mail, paid media, outbound calls we might make, a chat bot. So there's a whole variety of channels that a company will communicate with, and that clients increasingly expect that they're able to communicate with you on. Across those channels, now we have a set of lines of business, and these would just be some of the samples at Vanguard, but your company would have the same different lines of business that have different messages, of course, that they want to give to those clients across this set of channels. And then within those lines of business, they would have sales types messages, servicing type messages, support type messages. So as you can see, trying to coordinate all this, imagine a surround sound system at your home. Every speaker needs to be playing the same tune, obviously. If all of these speakers are playing a different tune, cacophony. And the solution is not, if they're all playing the same tune, is for them all to be turned up to 11. Like at your house, like all the speakers don't blast at full volume. So in order to create an omnichannel experience for clients that they actually want, you need to be able to play the right message on the right channel at the right time. And that is what we're kind of explore. And that's sort of a transformation that I think many companies are undergoing. Vanguard's certainly undergoing, and we're in the middle of that journey of how do you be that responsive. And I can tell you that really it's about automating, it's about real-time data, and about moving away from manual processes to automating it so that you can be responsive. So let's kind of unpack that. So imagine you're the mobile app developer for your company. So you're building the mobile app. You know about this disconnected experience problem that we talked about. You want to avoid that. So what do you need to know to create a connected experience? So I think about this a lot because I'm an omnichannel architect. So as soon as the client logs in, I need to know what does the client want to do. If the client wants to do something and I just show them a default experience, like I've kind of already failed because they've clearly showed intent. They want to do something on your site and you've shown them just sort of the default experience. So I need to know what the client wants to do. I also need to know what the client's been doing. So we talked about, like, if I call into the call center, I need them to know that 5 minutes ago I was on the mobile app and I had a problem. So that's another thing that I need to know. We need to know what we want the client to do. So there's a set of actions that the company wants the client to do. How do we communicate that to them? And then what are key attributes about the client in this moment? Maybe the client is nervous. This happens in financial services companies when the markets are down, when the markets are going up and down and crazy, clients are nervous. And so when we communicate with them, we need to know that. There could be other situations. The client might be a frequent caller. And if they're a frequent caller, then we respond to their needs in different ways. So we need to know the answer to these 4 empathetic questions. And When I started kind of on this journey, I think we can answer like none of them. So, I was on the mobile app team, and we rebuilt the mobile app from ground up. It was an awesome experience, but we didn't have personalization built in. What we had was a default experience, and everybody got the default experience, but no two people are alike. So in order to be contextually relevant to that person, we need to start building personalization in. And this is kind of what we'll look at. Part of the problem is the fact, and this is an organizational one, but I suspect it's probably common at many companies, larger companies, is the fact that we moved from monolithic kind of architecture. And so, for example, your website might literally be one giant deliverable, like one giant executable was your entire website, to breaking down that monolith to a bunch of independent web services, or independent, microservices. So there was a lot of advantage to that. Teams could deploy independently, and teams could just focus on their slice of the experience. But as you can kind of imagine, going from monolithic to now we have, say, a couple hundred teams working on in their own little slice, they're not very connected organizationally. And so therefore, they may know from their point of view what the next best action is, what are some key attributes about this client, what has the client been doing, but they only know it for like the 2 pages that they control. What about the entire site? So in order for this to work from a client's perspective, we need some of these capabilities or these building blocks to actually be centralized. So imagine we decentralized into breaking our experience up into hundreds of teams that now can, and the trade-off there was that they can independently deploy very fast and they can own their own slice, but now they lost the context of what's going on. Therefore, on the other channels or the other teams, and that's why it seems fragmented to the client. So just to kind of illustrate a little bit of how these next best action segments and client activity might actually be shown to a client, imagine the next best action, if we go back to the mobile app analogy, is we display that to the client as a banner ad or some sort of inline intervention. For segments, we may use that for personalization. So we would know, hey, this is a new investor versus an experienced investor, so we want to personalize content in that way. And for client activity, again, we talked about if a client is doing activity for channel switching, I'm doing an activity on one of your channels and I move to the other, I should be able to pick that up seamlessly. Or at least you should know or acknowledge that I did it. You shouldn't ask me to start over or explain myself. So we're going to look at those 3 building blocks and a little bit about what it takes to build them and kind of go from there. So the first building block is client activity. Answering the questions, what are all of our clients doing on all of our digital channels in real time? Every company should be able to answer that. It's surprisingly hard to answer. The way that we approach this problem, well, the capability is real-time client activity. And the first tool that we looked at was using Kafka to publish and subscribe. So imagine you have 300 teams that are all each own their own little slice of the client activity. We publish to a common set of Kafka topics, and then you can subscribe from that common set of Kafka topics and get an activity feed of what the client's been doing across all these different channels. This has been one of the talks earlier talked about designing for emergence. This has been one of the best, I would say, examples of that, where it's relatively low effort to do, but yet it yields some really high benefits, and they're emergent. So once you have, for example, a real-time event that people know, oh, wait, I can know in real time when clients are opening accounts, yes, then they will use that event to build experiences that we just never even thought of or that were never possible. So this has been one of those, I would say, leverage points that has been relatively low cost, but the key or the difficulty here is simply that it needs to be enterprise-wide, and that's no small feat. That if you can basically make the case that this needs to be done, it's a relatively low effort for the value you get. The second part, and the key there is real-time. The second part is being able to get our clients' clickstream in real time. Now, you probably use Google Analytics, or we use Adobe Analytics, or some kind of analytics for web and mobile. Again, when you're thinking about channels, there's way more than web and mobile. There's like 12 at least. But for web and mobile, moving from, hey, I know what you were clicking on yesterday to I know what you were clicking on a second ago is a big difference in what we can do for the client experience. So real-time data and real-time client activity, very fundamental. Let's talk a little bit, though. I said, we have these Kafka events and we have these clickstream events, like how are they different or the same? Why do you have two? Let's just kind of talk about how they are different. So a clickstream event is, like I mentioned, the button that a client clicked on, the page that they clicked on. It's the part of the user interface that they interacted with. Very valuable, very traditional. You almost assuredly have this. You may not have it in real time, but it's very valuable. A business event, what we're creating with Kafka, is something that, so for example, on the left-hand side, you see an open account event, which is a little cryptic, but if you kind of squint, you can see, okay, it looks like that, I can kind of tell that the client was on the open account page. If you look at the business event, you get a lot more context. And so that's really where the value is. Here you can see, for example, the client, the account number, the registration, their segment, a confirmation number. So business events are different than clickstream events in that they represent something that actually happened in your domain, like an account was created, a bank was added, a client logged on, and they are useful for different purposes. So I think both of these are complementary. In the past, we tried to use clickstream events to infer business, and it was really hard. So imagine you want to know like when a client begins and ends a flow. So when they click on this page, they begin the flow, then they go through some steps, and they click on this page, they end the flow. But we're also refactoring our website like 3 times a year. And so the page names change, and it's very hard to derive business meaning. So clickstream event, that's not to knock it. It's extremely valuable. But the business events are stable over time, and they're like a level of abstraction above clickstream events. So I'd encourage you to kind of consider business events. That's where we kind of have a sweet spot. That's where I talked about the bang for the buck. The other kind of event, though, that I want to mention, because there's infinity types of events, is a change data capture event, just to kind of clarify that the business event is a summary. Its purpose is notification of other systems. The right hand knows what the left hand's doing, and it is therefore, and it's also meant to be really represent a business concept. A change data capture event is much more about transferring state from one database table to another. It would include all the fields. It's not necessarily business readable. It's very verbose, but it's very important. I mean, we use change data capture events all over the place to replicate databases. But I just want to clarify, I'm not talking about change data capture event. The business event kind of stands on its own. And I think, again, there's other types of events, but I just wanted to highlight as they're talking through kind of like what was going through our head architecturally. Like, yeah, we need clickstream events. We definitely need that. We have change data capture events. What we're missing is this notification event in the middle, and that's what we built. I want to talk about another design decision, and that's around, this is not unique to events in Kafka, but it came up while we were building this, and it's around, if I want to deliver a piece of functionality, do I deliver it to you in a microservice that you can call, and the functionality happens there? Or do I deliver it to you in a set of client libraries which you can use and the functionality's there? I mean, it's kind of like the same code, really. It could be in both. But what are the pros and the cons, and what are the trade-offs? Because we had kind of a unique, somewhat unique reason to do this. So the first thing, the problem of what we're trying to solve business logic-wise, imagine, again, I have 300 systems, and I say, look, we're all going to coordinate by calling these set of Kafka topics, and we're going to use that to derive what clients are doing across all these systems. Well, data quality is really, really important. If I just say, hey, everybody have at it at these Kafka topics without really making sure that we have good validation on the events, all have like consistent fields, and we're using like the same serialization, what's going to happen is your Kafka topics would end up looking like your logs, and your logs are not readable to anybody but you. So in order to have this shareable across a wide organization, it needs to be very consistent. So that's the problem we're trying to solve here. Now the question is, for that data consistency, do you put the logic in a microservice, or do you put the logic in a client library? We went with the microservice for now, and we're going to switch to the client library because of speed to market. And the reason is, it's relatively quick to create a microservice. At the client library, we'd had to create in at least 3 languages, JavaScript, Java, and Python, to accommodate the services that we have. The second reason was we're adding these client activity events like left and right, so we're in a period of extreme change. It's very easy to change a microservice. That's actually like its real best value you get. So if I can change that 5 times a day, and you as clients, I have 300 clients, can call that microservice, that's fine. They'll get the updates without having to do anything. If I am changing my business logic that fast, I might have to come up with new versions of the client library like every day. And can you imagine the 300 teams are going to upgrade? They're not going to upgrade. They're going to upgrade like 6 months later. So the rate of change comes into this client library versus microservice, and the speed to market, the speed of initially developing it. So we started with the REST API. But there is a reason why long-term client libraries have value for this particular problem. And let me explain that. This is around message resiliency. And again, this problem is also not unique to creating events with Kafka, but what it is it's a common distributed systems problem. So imagine I have a producer, an open account service, and it calls this REST API, which is going to call Kafka to create an open account event, and it cannot call the REST API. Now, this will happen. All of your systems will at some point go down, and you need to account for that. In the current usage, for what we use these events for, what will happen is no events will happen for a short amount of time. So we will lose events for the period that REST API is down. And that's acceptable from a business case because we're using the events to personalize, to improve the client experience, and if those events are not fired, what happens is the clients get the default experience, but they don't lose service. That's not an outage. That is something that we can accept. And the advantage of being able, I mentioned there was a speed to market, the advantage of getting these events created fast rather than having to wait 6 months to create client libraries outweighed the small amount of events that we may lose if this goes down. However, we want to expand this. And when we expand it to use cases where events must be fired, they cannot be optional. So imagine a client places a trade and we want to send them a trade confirmation. That has to happen. Then this level of resiliency is not okay. This is where the client libraries can come into play, and why again, just architecturally, when you're at one level, when you need one level of resiliency, one architectural pattern may be the right trade-off. When you need another level of resiliency, then another architectural pattern. In this case, imagine we're using a client library and Kafka goes down. Now what can we do? We can build into the library a common pattern of store and forward. There's multiple versions of this. There's a listen to yourself pattern. There's transactional outbox. There's a lot of ways to deal with, hey, when I want to send a message and I can't contact the broker, what do I do? But we can build that into the client library so that every single user of that library benefits from that. And then when Kafka comes back up or is available, we can read from that backup message store. So just another consideration of where we're going in the future based on as our needs change with this architecture. Other kind of decision point was, okay, so we have these events, how will we use them? And there's 3 access patterns that we're supporting. And again, mostly to spur your thoughts as you build out event-based systems, what might you do with them? The first one is, hey, I want to listen to a single event. So again, many teams, hey, I can know when somebody opens an account. Let me give you a specific use case for using a single event as a trigger for a client experience. A team that can listen to when a client logs in. And so again, in a microservice architecture, imagine I'm the team that loads account balances. So I know when a client logs in, pretty soon they're going to be wanting to see account balances. And so I listen to that logon event and I prefetch data so that by the time the client comes to my service, now they get the data immediately because it's read right from cache. So I've sped up the client experience. I haven't changed the data access speed at all. The data access could even be slow. But what's fast is that I'm starting to load it sooner. So this is a case where using the client activity, I can actually improve the client experience by making things appear faster. They're not actually faster. The second area where I can improve the client experience, as we mentioned, is this channel switching case. And so this is what I actually want is when I am the mobile app or I'm a web page, and when a client logs on, I want to call a request response API to get back a list of what's the client been doing recently. So what's their activity? What are all the events they've done in the last, say, 8 hours? And that recency allows me then to build in, oh, okay, well, I called this API. I'm on the mobile app. I can see you've been opening an account on web. So I'm going to say, hey, would you like to resume opening this account? So the second access pattern of short-term history unlocks a lot of these kind of channel use cases where it's channel switching or the left hand can know what the right hand's doing. Again, the IVR or the call center could call this and discover what the client's been doing so they could connect you to the right person the first time. You didn't have to explain it to one person who connected you to another person. And then the final kind of use case with the we're supporting is the full ingestion. I just want all the events. I don't need one event. I don't need like your short-term history. I'm going to know your whole history. And that's useful for things like preventing fraud, useful for analytics, so reading those events into your data lake so you can have them for all of time, and doing things like customer segments, which we'll talk about next. But again, the highlight there would be fraud. So if I can see all events across all clients on all digital channels, then I can say that's a shady pattern. I'm going to shut it down. And again, so a lot of functionality out of trying this event-based client activity ledger. This kind of brings up this idea of a digital twin, which I've heard recently and been thinking about. This is not a new concept, but digital twin idea has been proposed or used in the past for imagining a virtual representation of a physical structure like a warehouse or like a manufacturing plant. But the idea where it could apply for customers in a financial services company, for example, is that in the past, every company has had data about their customers since they began. That's not new. What I think is new is recent trends have been towards consolidating that into what companies will call a customer 360 or client 360, trying to pool 50 to 100 disparate databases together to get a complete picture. But that in the past has been very much batch and very much not real time. If you layer on the idea of real time events, so now I not only know the client's data about the client, but I know their real-time behavior. And I also factor in real-time ideas about the environment. Again, in financial services, that might be whether the markets are going up or down. And add to that, which we'll talk about, real-time decisioning. Now I have the capability to respond to my client in real time. And let me give you a very specific way that can improve the client experience. But this idea of digital twin, meaning basically real-time client, a real-time client simulation, if you will, that runs all the time. Here would be one area where this really came to mind. If you think about clients experiencing errors on, when I've been involved with site reliability at our company, we have dashboards, we have Honeycomb, we love it, we have SLOs and burn down charts and these things. Those are looking at errors in aggregate. So if 99.9999% of requests are good, then our systems are good, we high five and go home. There's a problem with that though. If you look at the individual, the digital twin, the individual client, forget the aggregate, there could be, and there have been in the past, and they were very hard to find, times where only a few clients got errors, but they got like all errors. So it wasn't just intermittent. It was a few people had a terrible experience because they couldn't load their account balance, so they couldn't do a bunch of things. And their voice, if you will, was lost in the aggregate. You never saw it. But if you use the idea of a digital twin and say like, hey, we're going to take client experience and we're going to use these real-time events, and when clients get errors, we're going to use stream processing to say, hey, if one client gets so many errors in such a period of time, then we'll reach out to them or we'll do something. That I think really takes client experience from aggregate, or takes personalization really down to individualized, which is a lot of what we're talking about. Individually, responding to a client. So in that case, they're digital twin. The next building block we'll kind of talk about is, and I promise it won't all be as long as the first one, is segments. And so really this is about answering the question, what are key attributes about this client? And it builds on the foundation of real-time client activity. So if I know your activity, again, via Kafka or Adobe Analytics or other databases, and I apply stream processing over top of that, and again, we use a product. The product names are not particularly important. The idea is stream processing. We use a product called Adobe Customer Data Platform for this. In the future, looking at using Apache Flink. So if you're looking at like an open source version, very interesting. Then I can come up with key attributes about the client, such as I mentioned, this client's a frequent caller. This client is, and that might be based on their behavior. This is a new investor, and that might be based on their client profile. And I can use this segment data to personalize. And so why is this important? Well, the building block is stream processing, but why this is important is it acts as air traffic control. So imagine I have 300 teams that all own a slice of the client experience, and we want to personalize in a consistent way across all of them. Those teams need a service they can call to get a consistent set of segments for the client. Think of them as labels or tags for the client. So again, let's go with frequent caller. Then I can know across every channel, this client's a frequent caller, and I can personalize in that way. I can know this client is a new investor. I can know more specifically, maybe this client is looking for tax information. And so rather than have to code this special flag into every single application I have, which is going to take forever, I can use these segments as a key way of providing air traffic control to provide that consistent view of the client. So having a consistent segment API, rather than have every single channel have to come up with this on their own, is definitely one of the keys to providing a consistent experience, providing a contextually relevant experience. And we'll go with the final building block, and this is next best action. So this is a doozy. This is around what do we want the client to do. And the reason it's complicated is because there's a lot of people and process involved in addition to technology, but we're going to focus on the technology part. So imagine many lines of business all have a next best action for the client. So marketing has 10 actions they want the client to take. And again, different sales, service, support kind of messages or actions for the client. And each of them in an uncoordinated world are pushing their messages, which is just causing confusion. So one might be pushing one message or one next best action, and you go to another area of the site or a different channel, and they have a different message. The solution for this, or the thing that we're building, is a distributed decision engine. So imagine each of these lines of business can provide a service which, using events, publishes out the next best actions that they have for the client. So the NBA, or next best action, we're ranking them by their expected value or their value to the client. So meaning there's a propensity that a client would take an action, and there's a total value of that action. You combine the two, and that's our expected value. So if the action might be worth $10,000 in value to the client, but there's only a 1% chance they're going to take it, then your expected value is $100. So you're coming up with all of the next best actions possible for a client and allowing the domains to, in a pluggable way, decide that. Many of them will use common models like XGBoost, which you may be familiar with. This is like for a common propensity model. And so we're using machine learning in that regard, and then publishing those next best actions to a Kafka topic. Once we have the whole set, so we might have 100 next best actions for a client, then a decision engine sits on top of that and decides, okay, so of these 100, which is actually the best for a client in this moment? And the real key to that is the contextual multi-arm bandit model, which I'll describe. So the idea behind this model is you give the context to it. So imagine there's 1,000 attributes about the client that we know, and you give it to the model. In addition, the next best actions. So here's, say, the top 30 next best actions. Here's the context for the client. Which is the best one? The bandit will predict which is the next best action, but the key about this is that it learns, or it's told later, whether the client actually took the action or not, and so it's back to the individualized. It's learning for you. So at Friday at 10 p.m. on the mobile app, you might get one next best action. Did that work? Then on Monday at 8 a.m. on the website, you may get another. So the contextual part and the fact that we're individualizing this is really the secret sauce. And again, so you see another machine learning model is used there to kind of pick the right one. And the real key is that using reinforcement learning, it's learning individuals. So what are some design considerations? Why do we come up with this particular architecture? You could have come up with many other versions of it. There were quite a few. So the capability is a next best action engine. The idea sounds pretty simple. I have all these lines of business. They want the client to do all these different things. How do I pick the right one? Well, that needs to be centralized. We already talked about the fact of having multiple teams all make their own decisions is like a split brain problem, is exactly what we're trying to avoid. It needs to be individualized. I want to create this for the individual client, so therefore the reinforcement learning model. It needs to be value-based. What's the value? In this case, value to the client. And it needs to have real-time context. I don't want to know that what you did yesterday, I need to know what you've been doing recently. Because, for example, and this happens today, if we would suggest something to a client and then they would choose to do something else, then, if we would suggest something for a client and they take the action, then we don't want to keep suggesting it. So we need real-time context. It needs to be omnichannel. So this is something where it needs to work across all our channels because we're trying to get rid of the silos. And we also need governance, human-in-the-loop governance. There's a concern with the business, with our, I think many people, but certainly business folks about, well, if I turn this over to the machine learning model, what if it suggests something that I don't want? What's going to happen? I'm going to lose control. And so building in that governance and making the business units comfortable that, yes, the machine learning model is going to pick, but that we built in enough checks and balances that it's not going to pick something off the wall is an important design requirement. So the decisions, based on all this kind of capabilities, turned out to be, hey, we need this distributed decision engine, which we talked about. We have multiple lines of business, so it needs to be able to plug in. A mistake would be, like an alternative would be, we're just going to build one massive model, and it's going to take everything in the company in. That won't work. Having specific models that work together, and you'll notice in this decision engine, the blue box is a machine learning model. There's other white boxes, which are business rules. They're code. So just a recognition that this is not one giant machine learning model that rules them all. A decision engine is really business rules. Some of those do not need to be in a model. Machine learning models, and they work together to actually create a decision. We also wanted to use reinforcement learning models, as I said, because that's the individualized part. We're trying to move from generalizations down to individualized. And then the building block here was machine learning models. That's one of the key. XGBoost is, again, if you're looking to kind of look more into this, XGBoost is a propensity model. And Mab to Rec is an open source contextual multi-arm bandit model. It really is, it's a Python package. You can run it locally and kind of really understand how it works. I've done that. I'm not going to do it here, but it's very accessible is really what I'm trying to say. They have a good test suite, so if you can go into the test and try to see like, oh, I get it, how this thing actually works. And we also wanted this to be real time, as I mentioned. So once the decision engine makes a decision, it's going to publish it to yet another Kafka topic. And the reason behind that is we have multiple subscribers for this. So this idea, you can see event-based, once you get started with event-based and once you get started with real-time, it's going to start to flow through your systems because the slowest part of your system is what's going to determine the speed of the entire thing. So once you get down the path of real-time, moving to more event-based and real-time, starts to make sense. So here's kind of another just thought, and this is around the idea of the connected brain. As your company, or as you look at, this is just my thought on machine learning models, just like we want our systems to be connected, it's really important to have our machine learning models be connected and to not have them be one-off and be making completely independent and siloed decisions. So you could kind of see in that decision engine where several models work together. But the idea is over time, and this is a challenge which you don't necessarily have solved, but this idea I think is solid. As we have different decision engines, different machine learning models, that they need to be kept in sync. And some of the early thoughts we have are about making them event-based, which is not the typical pattern. Usually machine learning models are request-response-based, but adding kind of an event layer onto them so that the decision from one engine can be made aware in real time for another engine. And so just wanted to throw out the idea of the connected brain. And as you look at machine learning models proliferate kind of within your organization, how can they be connected? Because if they're siloed, we'll end up with the same problem with models that we have with our microservices, which is they're all doing random things. The other kind of factor of the connected brain to consider is that every vendor is wedging AI ML models into their product as fast as they can. And how will we integrate those models with the models that your team maybe creates custom? So just an idea, and it's one that as architects, we really have to wrestle with, or we will end up with split brain or 10 brains. And already that's a challenge. The other thought is that Gen AI is here to help. I know that there's a lot of thoughts around, hey, is Gen AI ready for prime time? It hallucinates, it gives clients bad facts. We've seen some really comical examples of where people have rolled out chatbots a little too early and it said like nonsensical things and the company was liable for that. In 2024, though, there are some, at least in the space of improving the client experience, some very specific ways that I think Gen AI can help that I just wanted to highlight. The first is in navigation. So Vanguard has for our website roughly 1,000 URLs. No matter how good you are at navigation, and our teams work really, really hard, and they do try to provide really good navigation, you cannot provide menu-based navigation for 1,000 pages. Like, it's just not possible to do that well. And Gen AI does a really good job of understanding when people talk and what they really mean and mapping. So I think there's promise now in mapping what a client is asking for to the right navigation quickly without forcing them through menus. And the risk is relatively low if you give the Gen AI model, if you give the LLM a constrained list of things it can pick from. So therefore, it's not just making up random URLs. The next area where I think Gen AI actually is prime time ready to help in 2024, again, still evolving, but is in the idea of call center agent assist. So imagine you call up to the call center, and this is like a heads-up display for the human who's talking to you. The model is interpreting what you say, and depending on your request, prefetching data and providing that to the agent so that they can more quickly respond to you. So I think this idea of agent assist is available now. Certainly vendors are claiming it is, and so it's just another area to look at for Gen AI in 2024. And the third is really about content variations. I'm not referring to Gen AI generating your website. It may do that at some point in the future, but not in 2024. But what I am referring to as we talk about personalization, and I want to get down to an individualized content for you. Why Vanguard has 10 million clients. Why don't we have 10 million versions of the website? Easy, it's cost. It's way too much expensive to create that many. But using Gen AI not to create it on the fly, but to create them, we talked about segments, to say, hey, for these different segments and this different content, I'm going to use Gen AI to help me get a starter for creating content variations. And then when a client comes to my website or my email or my mobile app, I will have used that to speed up what we call the content supply chain. That's a very valid use in 2024. And again, it's assisting writers, but in a really significant way, because when you go down personalization route, one of the first barriers that you hit after the technology is scaling content creation. So let's kind of put this all together. If we look at the distribution of a next best action. So client comes to the website, the mobile app, or the contact center. We talked about there's a decision engine. So it takes the next best action from each of the lines of business, inputs that, runs a contextual bandit, and determines what is the best next best action for this client given this context. That's published via an event to an API, which says, okay, based on that client's segments, I'm going to enrich that with content. So now I have the content for this client, and it publishes it out to the channels in the form of JSON. So it may have name value pairs, and this is server-driven content. So name value pairs for something like first name, headline, main image, and as well as the template that this content should be displayed in. And then the channels have already pre-created these templates. So imagine we say, hey, for next best actions, we're going to choose these templates. Like, this one's going to have a headline and a button and 2 images. And this one's going to have 2 buttons and an image or something like that. We've already created the templates, and so now we push that out, and it renders it for the client. In this way, we've been able to get a contextually relevant next best action to a client in using real-time events as a basis and real-time decisioning on top of that, versus the old model of, we came up with some message, we ran it through a manual process, we published it to the website, and we changed it every 2 months, or something like that. And so just to recap, the omnichannel, if we look at the omnichannel building blocks, we talked about event streaming as being one of those fundamental ones. It really is something where there's a lot of value for the cost. and being able to use that for use cases like channel switching or resuming an opening account. We looked at stream processing. We take those events and then process them to come up with key attributes about the client in the moment. And we can use that to personalize content. And on top of that, AI ML models that help us determine what do we want the client to do, and being able to publish those next best actions using server-driven content out to make a more contextually relevant experience for our clients, hopefully reducing frustration and improving the overall experience. So those are my omni-channel building blocks, and happy to take any questions.
So you talked about how you were publishing the events right now to a service instead of the libraries, but then moving on to the libraries in the future. How do you balance the risks of a service failing and that resiliency versus the risks of wanting to make changes down in the future and not being able to because the consumers aren't updating their libraries?
Yeah, it's a great question around, hey, the resiliency you get from building in resiliency to the client libraries versus the speed you get from updating the microservice directly, and kind of how do you balance that? I think in this case, the balance really will come down to we'll stick with the microservice until we can't tolerate the resiliency, until we can't tolerate missing events. And then we'll move to the client libraries, but incur the exact problem that you mentioned, which is now we're going to have, from the very first time you do it, if you're trying to get 300 people to use one library, they'll start to deviate in terms of people not upgrading. So I think you have to be careful in making the libraries backward compatible, but inevitably we'll run into the issue of, which I'm sure you've seen these fire drills at your company, there's a critical feature that we need to upgrade in some library. Everybody by Tuesday, please, upgrade this, and those are horrible. And I think those are just kind of like the pain of client libraries, which are why we didn't go with them out of the gate, even though they have a lot of value, especially because, like we said, they can provide more resiliency. I don't know if anybody else has any thoughts on that in the room. That wasn't a great answer to the question of how do you balance that, but if you have any other thoughts around how to do that. Yeah,
I mean, actually, the solutions aren't mutually exclusive.
Yeah.
So you can have your REST client that's able to persist.
Sorry. The two solutions aren't mutually exclusive, right? You can have a REST client that has extra things built into it to save the requests that would be sent to the REST service, just like if it was a messaging client. And so you still have the REST service that acts as the gatekeeper, the enforcer of the messages you publish on the topic. But you can still build that type of resiliency without abandoning without having to have a messaging client. You can stick with a REST client for the service.
I like that.
Just a thought.
It's a good thought.
I'll get him and then I'll come around.
Thanks. This is really cool. I've never seen anything like this. It's looks very complex, and it seems like it adds a lot of value to the clients, but it's very computationally expensive. I imagine when doing this kind of implementation, you need to justify your implementations with how much it's going to cost. How'd you go about that? Whereas it doesn't look like it's adding a ton of it, like hard value right off the bat. I don't know. How did those discussions go for you?
Yeah, it's a great question. It is complex. It definitely adds complexity. When you go from, hey, we're going to personalize in 3 basic categories to now we're going to try to go to individualized. At my business, their appetite for this is so strong that it actually was not, it was the other way around. They were like, how soon can we get to individualized recommendations? Because, and here's kind of the backdrop, we've modernized our infrastructure, we've modernized our front ends. Like I mentioned, I was on the team, we've rebuilt the mobile app, but yet I still don't feel as a business like that we are able to utilize this digital channel to essentially influence people in any greater way than we were before. And we still have these complaints about, so a lot of it came down to cost. So when I talked about improving your digital channels has a side effect, if it's done well, of reducing the number of people who call. And in many businesses that have a call center, the calls are very, very expensive. So I think the cost justification is we have this massive pile of calls. We feel like they can be served digitally, but clearly there's something not good enough about the digital experience, which is leading people to call. And so I think that particular, straight up dollars and cents rationale existed for this business. But I could understand for others, they may be like, hey, that's really cool, but I don't need a digital twin. Yeah.
There was a question over there that was before. All right, so I know you have Honeycomb at Vanguard, and Honeycomb loves wide events and letting you analyze them any which way. Do you send these business events to Honeycomb for any developer to look at?
We have not, and maybe I can talk to you afterwards. Our thoughts were like Honeycomb's you had a different set of telemetry, but the idea of them being in, but yeah, so maybe talk that through to me. So like we have a set of business events, and
For instance, the errors.
Yes.
You were worried about, sometimes one client sees all the errors. You can make a trigger on that.
yes, that actually sounds like a very good one.
Thank you for this session. Sometimes I felt like I was sitting in my own design sessions while I was looking through all the problems that you were talking about. But a couple of questions, like on the library for ingesting the events versus the API. We use APIs and libraries in different places, but on the API side, we saw a lot of compliance fall off with the producers as they were updating their systems. Not all of their systems were publishing events with the same attributes or the enums. How difficult was governance for you when you were going through the API side of it?
Yeah, good question. So
I have one more.
making it impossible basically to produce a bad event, having the validation was kind of one of the core reasons we built the API. So the API does validate, it validates the enums, it validates the structure very strictly. So in that case, if you are a producer and you call this REST API, like it does quite a bit of validation to make sure that you can't produce a bad JSON structure for your event. So in that case, now you can also do validation in other places, like Kafka has schema validation, things like that you can add. But that was like one of our main reasons for doing the REST API. So I think in that case, it's worked. But we had the advantage of knowing that was one of our main goals. Like data quality was super important because many teams, including analytics, fraud, whatever, want to use this data, and I can see it being used for a long time. So one of the things kind of unique to our business, we have clients who only interact with us on an annual basis. So this data needs to live a very, very long time.
On the content side, you said you started using Gen AI to generate content.
Mm-hmm.
Was there a measurement in, like Gen AI gets expensive as you're running more and more models. Like, did you have much of measurement in how much it improved containment and things like that versus how much you were spending on the Gen AI?
It's a great question. We use Gen AI for content for our writers through third-party tools that integrate it. So they're able to kind of accelerate on that regard, but I don't have, it's a good question of like, you have to pay for that stuff, so what's the return on it? I think if writers have generally been enthusiastic, but you're going to get the same kind of, I'm sure you've seen just in general, reactions people have towards like, if I'm a coder or if I'm a writer, is Gen AI going to take my job kind of, thoughts, and how enthusiastic people are to using it as a helper, which is what it is now. So, yeah. Mm-hmm.
Thank you. I kind of have two related questions. One of them being about the digital twin. Is it possible in the future, especially as we're able to kind of gather more data about these clients, that the digital twin becomes almost its own form of like personally identifiable information when all that data is kind of centralized together? Is that something that we would have to like take in consideration into like how we, I guess, store it and deal with it? And then my other question is, are we worried at all about certain like suggested actions revealing things about the clients, like if there was like a spouse account and one spouse logs in and sees, oh, would you like to continue moving $1 million to your secret second child's account or something? Yeah.
Great question. So the first one is around storing and using personalization data as PII. And it's like all PII. So I don't think, though, that the digital twin concept or the idea of gathering it together changes that. It's really the difference is that we kept it in scattered places before and we're bringing it together where it's far more actionable. But I don't think it fundamentally changes it. There is a concern, but this is just generally PII, is just that most companies use many different SaaS vendors now where they used to keep that data all kind of within their walls. And so how do you manage that? The risk of storing personally identifiable information at a third party, and what if they get hacked? But that's sort of a general PII problem. The other question, but I don't think it fundamentally changes with what we're talking about today. The other question is personalization creepy? So I've worked with a coworker, and I explained to him what I'm doing. He's like, I think it's awesome what you're doing, but I hate personalization. Like, I don't want them to know anything about me. And so that is 100% something that, it's just because you can, should you? So how do you make this benefit clients, them feel like, hey, this is just exactly what I wanted, versus cross the line, many famous examples of people getting, companies getting overzealous and using like their purchase information to infer things about them in their personal life that they didn't really want revealed to their parents. And so it's valid. And I think in my business, we're just starting. So we're kind of on we're trying to prevent this from being friction. Like when I call into the call center, they know what I'm doing. That's great. But the creepy side of personalization, I think, is where you know so much about people in real time that it can feel intrusive. It's something we really have to figure out. And the other thing is, which I think will happen, how will you clearly let people opt out? If they're like, hey, no thanks. I actually like the vanilla version. I don't want you to know that I, whatever, over anticipate my needs. Yeah.
In the architecture we have seen, first of all, thank you for that sharing information. In the architecture we have seen Kafka topic. So what are the thoughts behind choosing Kafka? Because we have SNS topic and Kinesis streams and also.
Great question. So, hey, there's a lot of messaging options out there. Why not SNS? Why not using some other tool? So SNS this is certainly preference. You could use a lot of different ones, but the general idea is that SNS, I think, is great when you have it kind of in the small, when you have a few participants and you're going to communicate, like a couple services communicate with each other. Kafka excels at what I'll call messaging in the large. It's very low latency, and in this case, the driver to it was this is going to be a set of Kafka topics that we're literally going to share around the entire enterprise. So hundreds of systems are going to use it. So we're prioritizing scalability, and we're prioritizing some of other Kafka's benefits are it's very tolerant of large message sizes. So it's more of a distributed log than a message queue, which you might know. So you don't have to old school message queues are very touchy about how long you leave messages and queue depth. Kafka doesn't care at all. You can leave messages on there for as long as you want. You can have multiple different readers jump in at different times. It can handle load incredibly well. And it's extremely battle tested. So we looked at like the enterprise-wide sharing solution for messaging. Kafka definitely bubbled to the top. Not the only one. There's plenty of others you could have picked. The other thing, if we just add on to that, is that many other companies use Kafka to integrate between companies. So I'm aware of two companies that one purchased another company and they use Kafka to integrate their trading systems just to keep them in sync. Well, that's like a lot of throughput. Like trading systems are super touchy to latency. So there's also a lot of examples of using it for industrial strength. Now, again, that is not, I do not get a commission for Kafka, even though I sound like it. But and I've been very happy with it at other places I worked as well. So those all kind of factored in, but you could certainly use other choices too. There's nothing magical about it for what we're doing.
We are also using Kafka for our implementation.
I love Kafka. If that wasn't apparent.
All right, I don't know a whole lot about Kafka, but I have worked with ESBs before in event orchestration, and when you're talking about omnichannel surround sound and empathetic questions about tracking client activity and not losing any of these events and understanding what's going on, have we looked at or has Vanguard looked at an enterprise service bus, or does Kafka provide ESB-like functionality to orchestrate events, publishing and subscribing and persisting so that we're not losing them and we can actually track all the client activity?
It's a good question. So I'm going to give you my opinion of ESBs, but I would then love others so ESBs, I'll just pick one, and maybe it is an ESB or maybe it's not, but is a product called Tibco, which I've experienced in the past. Tended to be sort of like this hub and spokes model, did not just pass messages, but also did transformations, so kind of like ran business logic in there, and mixed a couple different things with just pure messaging. I think Kafka's called a distributed log. It's more of like the pure messaging. For what in my opinion, big opinion, so ESBs are too overly complicated and kind of faded, in terms of their popularity. But again, I'd love to hear from others. You may be using an ESB and love it. So I think that you get the benefit of publish subscribe is really what we wanted. A very simple thing. I want very reliable, very low latency, publish subscribe, and that's it. And then we talked about stream processing, which maybe ESBs provide a little bit, but in this model, you have a messaging system, and then you have a stream processing system, which does things like, hey, windowing. If this event occurs, if a client places a trade, then I expect an email confirmation to be sent within 2 hours. So windowing, I'm looking for this event, and then I'm looking for this next event, and if it doesn't happen, I fire off, I execute something. So in some ways, that orchestration maybe that ESB provides, I think you get through the combination of event sourcing and stream processing. But I will look to the room for other opinions on that opinion.
I had another question related to NBA, next best action. So as I see the architecture, actually a lot of processing going on to derive that. So let's say out of so many next action lists, it comes up with whatever few list, like a derived list. So how do you really determine the value, like whatever next best action got created, NBAs got created, and the client, are they really taking any action based on whatever you have displayed? And is there any way to quantify, like whatever you are spending on generating those NBAs, is that really generating that value, equivalent values for the client?
So I think I understood. So definitely talking about generating the value. So the NBA providers, imagine the line of business that knows these actions really well. And so let's make it like super concrete, but also super generic. Maybe the next best action in this case is download the mobile app. Why do we want you to download the mobile app? Why does anybody? Because you can engage more in a digital channel, because the mobile app goes around in your pocket with you, because we can send you push notifications. So it may be a more responsive channel. So if the next best action is download the mobile app, then the team that is interested in that, the business team they have the burden of deriving the business value. So they know downloading the mobile app, we know generates essentially on average this much in value. So that's like part one. I think the second part you answered was, and then we are tracking whether the client actually took the action. I think you were saying like, well, let's just say the value of downloading the mobile app is X, and the client takes the action. Are you factoring in the cost of this giant omnichannel system and discounting, that? And I think generally yes, because it's included in kind of the operational systems cost. But I don't think specifically saying like, hey, generating this next best action costs $3, downloading the mobile app generates $40, so the actual value, we're not quite at that level, if that was the question. I will say, as much as it seems complicated, and there's definitely complication, generally speaking, what we saw with Kafka, with running machine learning models on Amazon, AWS SageMaker, and some of the other things, it's not actually super costly, I will say. This is a relatively inexpensive system built with open source in terms of like software licensing and operational costs. Now there's definitely a big buy versus build. As soon as you walk into next best action, there are many commercial products that will generate what usually is called next best offer from a sales perspective. And so that's another factor that we did not get into. But a big one, if you're anticipating doing something like this, buy versus build, Adobe has an entire suite surrounding personalization and things like that that are worth considering. All right, we've run out of time. Thank you.